Good morning, everyone. Thank you very much for the invitation. It's fantastic to be here this morning and do a bit of a framing session ahead of the 3 days that you have to discuss all the pertinent issues affecting AI. I've been working now in the energy sector for the past 18 years with a real passion driven by how we use energy, and that being at the heart of everything we do in society and our economy. And now there's a new kid on the block. And that new kid on the block has real transformative capabilities for us with our economy, and that is artificial intelligence, with great potential and applications that are deeply intertwined with energy and our energy consumption, usage, and operations of our systems. However, we as an industry are already in the midst of two pretty large-scale transformations that are happening, both decarbonising our power generation and electrifying the economy. And this poses an interesting juxtaposition for us. So at National Grid, we are right at the heart of those transformations. We're building a bigger, smarter and more resilient electricity network, delivering a surge in investment with assets as far as infrastructure, and to make sure that that's operational through the rest of this entire century rather than just for the foreseeable future. And it really is a once in a generation opportunity to reshape everything in our energy landscape. But what am I going to talk about today? Sorry, jumping ahead too quickly there. So I really wanted to talk about that technology transformation that's gathering pace with AI and the surge of data center demand that is also slotting into this pretty complex picture that we already have of those transformations that are underway. And that may be creating a few bumps in the road for us, but also offers the opportunity for us to really accelerate the energy transformations that are already in train. And at National Grid, we are squarely focused on delivering for our customers, including data centers, which relies on understanding the needs and also what we can do to actually help and assist. So today in the presentation, what am I going to talk around? So I'm going to talk around, first of all, what's happening with energy. Secondarily, what's the challenge and the fantastic opportunity that AI can actually create for us. And then what's being done to help us power AI Britain. So first of all, let me start by giving you a sense about National Grid's role in shaping a secure, reliable and resilient energy future for our customers and communities. Well, first of all, we are a transatlantic business operating in both the UK and US, and actually it's a bit of a fair split. 55% is in the UK and 45% is over in the States. That gives us a pretty unique perspective and a wealth of experience that we can apply across everything that we do. So in the UK, we own and operate an electricity transmission across England and Wales. And this is fundamentally like the backbone of our energy system. It's sort of the energy system, electricity system superhighway. And it connects everything from EV battery gigafactories to our local distribution networks, which then transports it all the way to people's homes and communities. We also, as part of that, operate within our electricity distribution part of the network as well. And that means that we are serving approximately 8 million customers across the Midlands, the Southwest and South Wales as a distribution network operator. We build and we maintain the network, which also has a functionally separate distribution system operator as well. So that's responsible for the system planning, network operations, and also provides flexibility services to make sure that we can manage in real time. In the US, we are active in New England and New York State, where we own and operate electricity and gas networks, and we directly serve 6 million customers. But our work doesn't stop there. Through National Grid Ventures, we are able to develop and operate energy assets in both the UK and US, and that includes transmission and also battery storage. And here in the UK, we have a fleet of 6 interconnectors that connects us as far as our mainland, what we have in the UK with mainland Europe. And our venture capital arm, which is our National Grid Partners, is based out in California. And that invests in startups that are driving technological innovations to solve challenges that we currently face and those that we may face in the future. So across both sides of the Atlantic, we are not just operating and building, but we're innovating, investing, and really doing everything we can to deliver a secure, reliable, and resilient energy future. So let's bring that to life a little bit, shall we? So let's take a brief look back at where we've come from. So the grid has been the centre of previous key shifts in Great Britain for a long time now. So in the 1950s, our national transmission network was energised for the first time. And that was actually supporting a post-war economic boom and a real shift to electricity use as people were moving from how they were heating and electrifying their home or being able to see things and use them in their home to different forms of energy usage. And really, in the 1950s, it was pretty much designed with the future in mind to make sure that we could easily update, we could maintain it, and we could integrate technologies which weren't yet developed. While it has expanded and developed over the past 70 years or so, responding to all of those changes, for example, the changing role of coal or gas or international connections and the rise of renewables, it has served us really well. And we are right at the point now where we continue with a huge amount of work across our networks to respond to some of those changes. So that means that what we're looking at is connecting new generating assets. We're also looking to power new demand, and we're also replacing any of the aging technologies which may have been around for a while, with also driving that lifeblood of innovation at the very heart of it. So we're really embracing this challenge, one that I'll talk about a little bit later on around sort of the great grid upgrade that we're undergoing and how that will bring a big overhaul to electricity grid in generations effectively. So a few other examples of what we're using. So we're using, for example, digital twins from a platform called Sensat, and we're taking new approaches, for example, deploying smart sensors and drones to detect network issues that might unfold. We're really doing with this in mind. We're thinking, what does this need, not just for the next 40 years, but really what could that look like by the end of the century? So similar back to our forebears back in the 1950s. So I mentioned two transformations that are underway. So let's hone in on the first one. So our power sector is different and it is going through that change. And it's quite different than where it was 15 years ago. You know, a few years ago, if we were talking about the energy transition, it felt like it was something that wasn't going to happen for a while. And we're actually already in the thick of it. And what we're doing is we're moving from a system that was historically dominated by large fossil fuel plants that was near demand centers, so coal pits were sited very close to where people lived, versus what we have now, which was a more diverse mix of renewables spread across the country, often in some of those remote places such as offshore wind farms. We can see the benefits of this because we're seeing a drop in emissions as coal has been taken out of the system a few years back. And the government at the moment is extremely ambitious, looking at the Clean Power 2030 target to see how we could run our power system on low carbon sources 95% of the time, underpinned by further growth in key technologies and also looking at flexibility to manage that system. This change means building out the grid and connecting new generation and storage at a scale and speed that we haven't done before. And National Grid is playing a really key role in strengthening that as we move forward. And while electricity demand is not seeing the same geographical reorganization as generation, the type and scale of demand is also changing significantly. In Britain, National Grid has spent several years refocusing on activity around electricity networks because we believe it delivers the best long-term outcomes for the consumer and for our country. So let's start with the big one. Transport is electrifying. EV adoption rates climbing alongside other modes of transport such as rail. Domestic and en route public charging points are replacing petrol and diesel value chains. The UK has predominantly relied on gas for its heating, but heat pumps have seen significant improvements, and the electrification of heat will drive further power demand. And finally, industry in itself is playing an increasing role in turning to electrified processes. So transformation on this scale, it's happening, but it's complex, and it's vital that for Great Britain PLC, we are undergoing a balance of our priorities across affordability, the environment, and security for us. So with those two transformations underway, we've also seen AI has burst onto the scene in recent years, but it's not an entirely new disruptor. National Grid has been using AI for decades, but rapid improvements in the scale of the applications have seen quite a rapid step change. We're seeing expanding use cases for AI within our own business, but this is just a small part of the opportunity for Great Britain. At the global level, projections of a 7% boost to global GDP, and considering that the UK, specifically the International Monetary Fund, estimates that AI could boost the UK's annual productivity by 1.5% a year, which would be favourable for where we're at currently. The UK government has set clear growth agenda, and AI offers a credible route to delivering that growth agenda by enabling investment, supporting high-value jobs, and strengthening the digital foundations of our economy and our expertise. We're already seeing the proof of this, so we're seeing regional boost of investment in AI and data centres, and AI was at the core of the UK-US tech prosperity deal that was agreed back in September and accompanied by over 31 billion of investment into the UK's AI and technical infrastructure. And there are large projects. Google have recently opened a new data centre in Waltham Cross as part of its 5 billion investment to power UK's AI economy. And AI offers opportunity for the energy sector and National Grid, opportunity from innovative new technologies to make sure that we are efficient in that dispatch of generation. So we estimate that AI has already delivered us 100 million of value across customer engagement, asset management, and operations. But there's a real case of AI also helping AI. So let's get to the crux of it. These transformations are significant, and they have also gained significant momentum. There's raised lots of questions for our sector, and ones which need to be resolved soon. And indeed, the entire structure of our energy system is evolving in that response. Our energy system is complex, with multiple actors playing vital roles, from generation to supply, within a regulatory environment that is led by Ofgem. The National Energy System Operator, which was established back in 2024 and previously owned by National Grid, is now part of government, or an arm's length organisation to government. It has expanded responsibilities and has been at the forefront of this shift. To manage the growth of clean generation and networks in an efficient and coordinated manner, NESO is leading on strategic planning, shaping the energy system of the future, and will shortly publish the roadmaps for the energy system from 2030 to 2050. And alongside Ofgem, driving connections reform, which is a hugely significant milestone. So we believe it has real potential to progress our long-stated aims to reduce and reprioritise our connections pipeline, moving us to a world of first ready, first needed, and first connected. This is focused on generation previously in connections, and that now being coupled with strategic planning will help us prioritise the delivery of assets when and where they are needed. But AI and data centres are adding to the scale of this transformation and require new approaches and action. So when taking a global view briefly, data centres are a significant source of new global power demand. Projections do vary depending on which news sources you're looking at or which particular consultancies are putting out individual reports. But one thing that is quite clear is the pace and breadth of AI uptake in its use cases also has potential to be impacted by the level of efficiency. But we are seeing an uptick in demand in the next 25 years, which could potentially be 12 times the current annual power demand of Great Britain. So before focusing on Great Britain and our network needs, it's important to reflect on the implications of power generation. We are already seeing how data centres are driving investment in generation, cutting across the whole sector, including repowering of existing assets, further growth of new renewable assets, and investment in emerging technologies, notably the development of small modular reactors. So Great Britain, and in particular London, with the strong financial sector and global connectivity as a leader in data centre growth, we can see there's a rapid uptick of data centre demand playing out in the near term, potentially tripling in the next decade. And across NESO scenarios, we anticipate data centres will be 5 to 9% of the total energy demand by 2030. But I think it's important to also state that data centers are not all created equal. There are lots of different types, and it depends really on the usage of them. So we have smaller enterprise data centers, which are connecting to our distribution network, and then we have large AI hyperscalers that will typically connect to our transmission networks. Now, historically, those data centers were centered or concentrated around sort of London and the Reading belt, but we are seeing greater geographical spread now, which increases the number of connection applications across our distribution networks. And traditionally, only a small amount of demand has been connected directly to our transmission network. However, we've seen a rapid increase in demand applications to the transmission network, driven in part by data centers, which continue to grow significantly in their footprint and power requirements, with AI hyperscalers seeking hundreds of megawatts of connection capacity. Since 2024, we have seen a 300% increase in solely data center connection applications in the transmission connections queue. And we know that time to power or connection wait times have often been misaligned with AI and data center business needs. And some of the key steps that are underway across the energy sector I referenced earlier, connections reform and strategic planning, have largely focused just on energy generation. So with that surging demand that's playing out, it's really critical, not just for us, but for the energy industry as a whole, to properly understand the needs case of AI data center customers and how we can help. At National Grid, we have been working better to understand data center needs. We've got internal findings that we have investigated and had lots of conversations with customers and engaged with them extensively, and really found out that some of the key things that they're interested in are about prioritizing a fast connection. They want reliable network and connection, and they're actually, gone too fast. They're also willing to pay for a secure grid connection. But power is not the only requirement that data centers are actually interested in. It's also factors such as location, which is driven by land access and availability, connectivity also to other infrastructure, and notably other utilities. So we recognize that speed is paramount for data centers, and unlocking that is a key to the full economic value that data center development can give us. And at the heart of this issue is the fact that it's far quicker to construct a data center than it is our energy infrastructure, and that we have limited spare capacity once accounting for the resilience requirements that we currently have for our network. We've taken great steps to reduce the build out time of new infrastructure, but it can still take maybe twice as long to deliver network capacity. So therefore, it's really critical that we see the changes to the policy and regulatory framework to ensure that networks can facilitate that growth alongside driving the innovation in the sector. So let's talk a little bit about some things we think will help with some of those solutions. So the first one we're really talking about here is unlocking existing network capacity. And we think that this, coupled with creating new capacity and managing the connections queue, will actually help us as an industry. So the electricity network is really designed to build in that redundancy to keep world-class reliability and lights on for all of our customers, and power as well for everything that needs to be powered. Capacity is typically available outside of peak events like hot summer days or cold winter storms, when there's high demand for cooling and heating. And that means in many cases, there's room on the existing grid if we're able to use it flexibly through innovative technologies and business models. We're already exploring these avenues at present and within our current regulatory frameworks, such as using flexibility to unlock further capacity from the grid, or alternative connection offers to allow data centers to ramp up their connection needs over time. So a couple of the examples that are here on the screen: Emerald AI. In September, we announced a strategic partnership with Emerald AI, a company whose platform enables AI data centers to flexibly adjust their power consumption from the electricity grid on demand. And this demonstrates how AI data centers can work with the transmission network to adjust their energy use in real time, making better use of existing capacity to support the UK's growing digital needs. Second one is another example, which is Bridgewater Gigafactory. So within our distribution business, we're building 2 interim 33 kV connections to power the Agratas site, and with temporarily until a high voltage 400 kV substation is built by our transmission network at a later stage. This ramp distribution to transmission connection really demonstrates how we can collaborate and also provide a model for future projects as well. And then finally, line vision. It offers a non-contact technology to monitor how weather and load conditions on the network can affect the line. So it tells us when we can safely use more of the given line's capacity, and it's also known as dynamic line rating. And it could increase up to 20 or even 30% of our network availability in some cases. And that high capacity helps us meet demand and accelerate new connections whilst avoiding unnecessary time and cost for new construction. So let's talk about the next one. So really creating additional capacity and additional headroom. With the scale of demand that we see coming, we need to take a more strategic approach, moving away from the model of incremental expansion to respond to customer needs. And with a regulatory framework that really allows us to invest ahead of need to make sure that there is capacity ready in the right places at the right time. So a couple of other examples which are adjacent to this, but in 2023, we took a major step forward collaborating with Ofgem to launch the ASTI framework. And the ASTI framework was a fast-track mechanism for critical transmission projects to be streamlined through a funding process to help us connect offshore. And that has actually helped us underpin a lot of the big work that we are doing in our business. We have our next business plan that's going through a final determination with Ofgem, which will be announced later next month. And in our business plan, we set out proposals to double the power flows across the country, helping to meet surging demand alongside delivering up to 19 GVA of new demand connections, equivalent to London's entire demand, where up to half of the capacity could be for data centres. In that anticipatory investment, the ASTI programme has allowed us to kickstart a scale of investment that's new to us. Historically, we would have only been working on maybe one major transmission project per year, but today we are pushing at great strength. So we have 6 projects that are currently under construction, 6 which we will submit for planning applications this financial year, and 5 others that are in stages of public consultation. And the scale of this delivery really raises another challenge for us around sort of the skills and the pipelines and supply chain capacity that we need. So back in 2024, we launched the Great Grid Partnership, which is a means for us to collaborate with suppliers to create some longer term certainty and build out that pipeline for them. And TS Conductor, as part of an innovation example, we're working with companies focused on improving hardware too. So multiple technologies involved in that. And one to sort of talk about here is that TS Conductor uses advanced conductors to provide up to 3 times more capacity than existing cables, and that will help us reduce the size and the number of transmission pylons that are required. And then finally, let's make sure that we manage the demand connections queue. So we've been working closely with government to support progress across key programmes that focus on demand. So the Connections Accelerator Service was announced in the industrial strategy, and it offers potential to create a formalised process for data centres and other strategic demand, thus allowing us to pursue more creative options to expedite connections. To date, connections reform has largely focused on energy generation, but with unprecedented levels of demand coming onto the system, it's important that we make sure that we think about this and how we can support economic growth. The latest regulatory thinking on this was published just last week, with Ofgem issuing guidance on demand connections reform and NESO launching a call for input. We are also seeing progress across other government initiatives, notably the development of AI growth zones, with multiple zones now being announced. And National Grid will really continue to support collaborating and contributing as much as we can, including being involved in what that looks like from an AI Energy Council too. So coming close towards the end of the presentation, let me just wrap up by stating 3 things that National Grid is really keen about and working on here. So we are really leading the way to a new energy era, building and operating the next generation of our networks, and that we think that AI and data centers will be a key component of that new energy era, and that together we can maximize the existing capacity whilst building new capacity to manage our connections, and that innovation is at the life heart of all of this and will help us unlock a huge amount of potential. Thank you for your time.
Amazing. Thank you so much for that, Abbie. I think it's like a really exciting time to be alive. It does feel like a whole new way of doing things, a new generation. Just the green energy transition in general. I personally find it quite exciting, and then add on, the demand from AI. We are kind of lucky to be alive during this time. I got very philosophical there. Sorry, my brain's working in a weird way this morning. I got back from a transatlantic yesterday, so sorry about that. We do have a question from Carl Turbot. With the increasing demand in the supply of electricity, are you taking harmonics into consideration to help take the pressure of the transformers and improve the process?
In short, yes. I mean, we are looking at everything, but I think it's also clear to understand who in the energy system is responsible for a lot of that. So part of the things which we have within our own asset management responsibilities, for example, the conductors and those sort of units, those are the ones that we are then considering. But then we have the system operators, of which we have one at the distribution level, but then they'll be looking at things like voltage, harmonics, inertia, and all those things to just make sure that we are leveraging our network and being able to make it as smart as possible to balance the load and the supply.
I imagine not an easy job, but something that, if anyone can do it, it's you guys. Because as you mentioned in your presentation, you have experience both this side of the pond and where things are a bit more advanced, other side of the pond. We're only just starting our AI ramp up, whereas they've been doing it for quite a number of years now. So good lessons to learn. I think that's the only question we've had from the audience. As I mentioned to you earlier, like, you never know. But if anyone else has any other questions, then do let us know. I will send them over to you, Abbie, if we get them after you've left. But for that, thank you again for your presentation.
Thank you. Thanks very much for the invite, and I hope that everybody has a very fulfilling few days and enjoy the rest of the conversations. Take care.